and welcome to another episode of FooBar. In today's episode we are going to learn how to model data to store in a DynamoDB. If you want to know more about serverless, cloud computing or software engineer practices in general, subscribe to my channel in the red button below. I post a video every Tuesday. So let's get started! So this is the second episode on this DynamoDB series that I started last week. In the first episode we talked about the basic concepts of Dynamo. So if you don't know what I'm talking about, you have never used Dynamo, or you have used it but you're not sure if you know everything you need to know, go and check that series. You can find the video link in the description box, and also I will leave it in a card up here. In this video we are going to start defining our app, we are going to start designing it, and then we are going to model the data for the app. So I will give you a brief explanation on the app that I want to do, and then we will move on to the slides and deep dive in the use cases on how we are going to do everything and how we are going to model the data. So the app I want to build for this example is like an Airbnb type of app. I will call it Airbnb because I'm very original. You know how good at naming I am. The idea is to use an app that is not as simple as a Hello World app or putting things in a database and retrieving it. I think it's good to use something that it's out there and you know how it works. So this will be a simplified version of Airbnb. The idea here, we will do the backend for it, not the front end. I will just build the backend for it, and we will work with some kind of visuals just to guide us on what we want to do. This Airbnb has some kind of basic functionality. The first one is, as a user, you can go and search for properties in location. You can book for those properties, and then you can see all the properties that you have booked. Then, as an owner, you can put properties in the system, and then you can see for each of your properties when it was booked. So it's a very simple use case, and that's what we are going to do. Sure, if you look at Airbnb, it has way more features, and we are just skimming it down to see how we can model that data in Dynamo. That's the core thing I want you to learn from this series of videos. It will be a very simple serverless application because we are not focusing on the design of the serverless application per se, but it will be working and it will have all the benefits of a serverless app. It will scale and it will work on high load if you do it well. So that's kind of the idea of this series. So now let's move on to my slides and look at the different use cases and what kind of data we need and how we can do some prototyping and data modeling. So in one of my favorite talks of reInvent of all the time, Houlihan talks about the steps for modeling the data for NoSQL databases and more precisely for Dynamo. So we are going to look at these 4 steps because I think they are very good steps and I use them in one way or another when I'm doing DynamoDB modeling. And we are looking at these steps during this video one by one and trying to model our data. The first step is to understand the use cases. It's very important to know if the use case is good for a NoSQL, that's very important, and also if it can work for Dynamo specifically. The second step is when we start grabbing those use cases and start looking at the access pattern for our data. The first step is to model the data into a table and indexes. And the last step is to try it out and review this and fix stuff and try again and start all over again and do it over and over again. So the first step is to identify the use cases. We need to answer some of these questions. What kind of application are we building? How our data relates to each other? Should we build an entity relational model? That's what Rick recommends. For that, I created some visual prototypes for the application I would like to build, so it's more easy to start building the use cases. So let's look at the prototype. So the first thing we have in this app is a list of all the properties, and we can get this list by searching by a location. We need to pass a city and a country. Then when we find the properties, we can click on one of those and get the information on that particular property. And we can see all the information from the property, and at the bottom we can see the dates that the property is not available. We could model this inside a calendar that is marked, that is not available for the purpose of my non-front-end developer skills. I will just list them here. Then we will have a button that we can book properties for some dates. And then we will have our user page where we can see all our bookings, the past ones and the future ones. And then if we are owners of properties, we will have another profile view that will list all the properties we own, and we can add more properties as well. So these are our use cases. We have 7 use cases that we identify, and with that we are going to build the entity relationship model. And here we can see I discovered like 3 entities: the bookings, the properties, and the owner. The owner is kind of blurry because an owner can have multiple properties, a property can have multiple bookings, and that's kind of the model. It's a pretty simple model. So now we can move to the second step, and in here we need to understand the access pattern for our data. Here some of the questions we need to answer are: when are the writes and reads happening? What are our data sources? What kind of queries and what kind of writes exactly we are going to have? So looking at our use cases, identify these access patterns. There is 7 access patterns, more or less one for each of the use cases. And here I can also estimate which reads and writes will be more frequent than others. So for example, here I can see that the reads are way more frequent than the writes. It's quite more common in my application that people will search for properties and open a lot of properties, then do bookings and see the bookings, and also for the owners to check the property. So the 2 top queries are the ones that I need to optimize because these are the most used ones. Now we can move to data modeling per se. We will try to model most of everything in one table. I like to do this, and I think if possible, if you're building a microservice in general, it's quite possible. In this way, you can reduce the round trips and simplify the queries and application in general. It's very important if you're modeling for one table that you are doing this analysis process quite carefully, because when you will see when we start modeling the data that the table is not as straightforward as and we will have many indexes. So if you need to recreate indexes and things like that, you will need to create a new table and you will need to migrate data, and that's also very painful. So try to do this process, iterate a lot if you are planning to use one table. At the end of the day, it pays off because maintaining these applications is way easier because the code is much more simpler than having a big application with multiple tables that you have to do a lot of things on the application to showing all this data and to keep the synchronicity of all the data. Also, during this data modeling process, I will make some decisions, some architectural decisions in my database. You might not agree with those decisions. Feel free to do whatever you want and let me know in the comments what is the best way to do it. I did this exercise and I found this solution, but I'm pretty sure there can be many right solutions to model the data. So please go ahead and let me know. So in the data modeling, we are going to identify everything that goes in the table and how the indexes are formed, what are our primary keys and our sort keys and everything. So we can start. The first thing I usually like to do is to try to start by our writes, because they will need to be kind of the base of our table. So I want them to happen whenever I need to add something in the table. I would like to have only one write and keep it as simple as possible. And in this example, we have 2 different write patterns. One is to add the property, and then the other one is to book a property. Let's start by adding a property. And basically, I will just put all the things in the table that I think that will look like that. So the property ID is quite a clear primary key, and then the rest are attributes. In this way, we can always identify one item. And also with this layout, we can get the property by ID query just by querying by property ID. So now we have solved 2 access patterns. Now let's move to the book a property access pattern. We want to be able to book a property. For that, we need to put the information in the table. how to decide which is our primary key and sort key is very important here. In this case of booking a property, we are not creating a booking ID. We don't need it, and we are not keeping track of booking ID. We can decide if we want to store the information by user ID or by property ID. So we have two options. In the option 1 is the one I will try now, and then we will try option 2. The option 1 is that we will use the user ID as the primary key, and then the sort key will be the start booking date. Why the user ID cannot be alone a primary key? Because with the user ID by itself, I cannot identify one property. I need to have something else. And a user cannot have two bookings on the same day. That's a rule for our system. So then if I have the user ID and the start booking date, I will get a unique item. We can go with this option, but then you look that the primary key in both entities in the table are different. We have the primary key for the property and then the primary key for the user ID. I don't know if the most efficient way. Let's look at option 2. In this case, we are storing the booking by property. So we are going to put the property ID and the booking starting date. Why again? Because with the property ID, we cannot identify one booking, but one booking cannot be booked on the same day by two persons. So then we can do this and find one item. And this, I think, is a better option because both of the primary keys of the entities that will be stored in this table are the same and will make my life easier later on. And then because we are booking a property and we are storing it by property ID, we will fulfill the get bookings for property access pattern as well, because now we can get with the property ID all the bookings for that property. Now we have a problem because we added a sort key for the entity that is the bookings, and our property entity now needs a sort key, because if there cannot be items with sort key and items without it. If you have a composite key, you need to have two in your table. So for that, we will add the string property when it's a property, and then we will have the start booking date when it's a book. Now let's move to another access pattern, and this one is the search by location. How we can do search by location? We want to search by city and country, and then we will get a lot of property back. So if we use the country as a primary key and the city as a sort key, this doesn't work because this doesn't return one property back. This returns, I don't know, as many properties there are in the city. And we need that kind of primary key to have only one result when we use it, that composite key. So for doing this, we will do a composite key that we will combine the country and the city together. And this will create a hierarchy because the country has cities in it, so it's no problem at all. And then we can use that country city composite key as our primary key, and the sort key can be the property ID. And then whenever we search for the primary key, we will get a list of properties, but then we can specify the sort key and we will get only one property. So that's how we want to do it. But then the next question is where I want to store this data. Are we storing it in the table or where? For me, the best place to put this data is to create a global secondary index and then project the data from the table into this global secondary index. So whenever we add a table, this data gets projected there and we don't need to do anything. It happens automatically, because if we store this data in the table, then we need to do, whenever we add a property, we need to do two writes in the table, one with the first property that makes sense, and the other one that is basically copying everything. And this needs to be a transactional write that we need to take care of. So to avoid conflicting, we just use a global secondary index that does this automatically, this projection of the elements automatically. And as we are creating this composite key with the country and the city, we need to add that attribute to our main table entity, because there we will need to project it as the primary key of the global secondary index, so we need to have that element there. So I will add it now to the table. Let's move to the next access pattern. This one is the bookings for users. So In here, what we want to do is to find all the bookings for one user. So this one we talked already when we were modeling the table. We want to use the user ID, and we need to have the start booking date, because with the user ID we cannot find one particular booking. We need a little bit more detail to find one particular booking. And again, you might be wondering where we put this information, in the table or in an index. The same answer as for the search, the get property by location. We want to put it in a global secondary index. So whenever a new booking is written to the table, it will be projected to the global secondary index, and we don't need to do anything. We don't need to write anything. It will happen automatically for us. The next access pattern is the get all properties for the owner, and then this is a similar one. We want to get all the properties for an owner, and for that we need the owner ID, and then we need a sort key, because an owner can have multiple properties, but then if we put the sort key as the property ID, and then we will have one item as a result if we search for owner and property ID. And again, the same question, where we put this in an index or in a table. I think we should create a different global secondary index and put the data there, so whenever we add a new property, it gets projected there as well. Now I will sort everything around, and you will see everything a little bit more organized, table and indexes, and this is our DynamoDB table looks and how our indexes will look. If you find a better solution, please let me know in the comment box below. I'm very happy to see how you are solving these problems. In the next 2 videos, we are going to see how to implement this with a serverless application, so stay tuned. But I want to show you one thing before you end this video. That is my repeat, review, repeat loop, because you have seen here a very clean line of code, and that was my last line of code. It was not my first iteration. So I want to tell you a little bit about some of my failed iterations, so you know a little bit of the process that I went through. So my first iteration was to put everything into a table. I thought, this sounds very simple. Let's put everything in a table without using indexes. The main problem here is you can do it and it can work, but the main problem here is keeping everything in sync. So for example, when you add a new property into the system, you need to do like 4 different writes in the table. One for the property, one for the bookings, one for the search, one for the owners list. And this becomes very complicated. You need to use the transactional write and add a lot of complexity into the game. This is not very efficient, so I discarded quite fast. Another iteration I did was to have one index and one table, and this one didn't even make it to implementation, because keeping an index and projecting indexes with different primary keys and sort keys is very complex. So I was like, no, this is very hard. Another iteration I had was one table and 3 indexes. Look very, very, very similar to the end result, but you can see here that the table doesn't have the property and the bookings by property, has the bookings by user. And here the 2 primary keys for the table are not the same. I will make it a little bit more efficient by having the same primary key as properties as we end up having. It's just a little bit of fine-tuning, but you can do that when you iterate and iterate. Some final notes. In order to make your life easier when you're doing the iteration, use infrastructure as code, write everything as infrastructure, so then you can remove, add, and it's way easier to keep track of your database, and it's just running some deploy. You don't need to do much. It's just changing a little bit of the code and deploying again. Another tip I give you is to use a repository. Put your code in a repository like Git, and then start tracking your experiments there. You can do something and it works, but maybe it's not the best solution, but just git commit that, so then you can come back later and see, so you don't forget what you were experimenting with, because sometimes you take one idea from one experiment and one idea for another experiment, and you put them together in a third idea, and that ends up being the final result. So keeping track of your experiment is very, very good. Another thing I will tell you, don't invest too much time putting data into your tables. Just put as minimal as you need in order to your tests, because Whenever you are iterating, you might need to drop your table and start again, because when you are creating indexes in Dynamo, if you are recreating indexes, you cannot do it. So you need to basically drop the index and start again, and that index will be empty. So it's always better just to drop the table and start again. So don't invest too much time filling your database. Just put as minimal as you need, and then when you have a more polished database, then you can add more data to test. Another final note is to have some integration tests that you can run that will populate your table with enough data to test. So you can have simple integration tests against endpoints that don't change. So they will be just calling the endpoints and doing all the filling of the database and querying the database and doing all that. And no matter how your database looks, those endpoints will always work, because you will have many different layers of abstraction in front of that. I will show you all these things in the next 2 videos when we are creating this. So don't worry if you don't understand exactly what I mean. You will see it in practice in my next 2 videos that are coming after this. This was the video for today. I hope you like it. If you did, give a big thumbs up. In the next 2 episodes of this series, we are going to go to the coding. We are going to build our application. We are going to create everything as infrastructure as code. We are going to model our DynamoDB table. We are going to test our application, and we will see it working. So stay subscribed to my channel, and make sure that you are notified when new videos are coming out, because these ones are going to be pretty interesting. And if you have any ideas for future series for 2020, let me know. I have some ideas for the next two months, but after that I'm designing what it will happen, so I'm open to suggestions. Around here there are other videos from my channel for you to watch, so go ahead and click. And I see you next week with another episode of FooBar. Ciao ciao!